Hi, everybody. By now, you should have already learned how to solve systems. I did a video on how to solve them by graphing and also how to solve them by substitution. I usually don't use the elimination method with my seventh graders. So in this video, we're going to focus on solving word problems by writing systems of equations. When we solve those, I'm going to go back to that substitution method. So if you're not comfortable with that, you should really rewatch that video first. Okay? Okay. So a system, you've got two equations. When we set these up for word problems, the easiest thing to do, make your first equation represent the total. And then the second equation will represent how the two quantities are related to each other. Let me show you what I mean, and we'll do a few of these here. Okay. First example, a total of 75 cookies and cakes were donated for a bake sale to raise money for the football team. Okay, we're going to pause right there because we have enough to make that first equation. I'm going to pick two variables. Usually I would use just, the first letter of each word, but cookies and cakes, that C isn't going to help. So I'm going to write down that I'm using X for cookies. And I'm going to use Y for cakes. I know that when I add them together, there's 75 of them total. So the cookies plus the cakes, or X plus Y, equals 75. There's your first equation. That is the worst 7 ever because I tried to hide a little mark that was there, but okay. Second equation is going to show how they're related. That's where this next sentence comes in. There were 4 times as many cookies donated as cakes. 4 times as many cookies as cakes. So you need to ask yourself, were there more cookies or cakes, and then figure out which one's going to be getting multiplied. So let's say if I know there were 3 cakes, I know there's 12 cookies, right? So whatever the cakes are, I'm going to multiply the cakes by 4, and that's going to equal the cookies. So X, the cookies, equals 4 times Y, the cakes, because there's 4 times more cookies than there are cakes. Okay, so now to solve this thing, I've already got one variable by itself. So I'm going to take that expression for X and I'm going to replace X in the other equation with it. So I'm going to rewrite that top equation, but instead of saying X, I'm going to say 4Y. Whoops, there we go. 4Y plus Y equals 75. I just pulled out the X and I replaced it with the 4Y. So that tells me that 5Y equals 75. Divide by 5, and you get that Y is 15. So I know that there are 15 cakes. Now to get my other one, my X, my cookies, I'm going to plug that back into either equation. I need to know what X equals, so it's going to be easier if I just use the one where it already says X equals. So it says X equals 4Y. I'm going to plug in my answer for Y, which is X equals 4 times 15. So I find out that X is 60. So there are 60 cookies and 15 cakes. Let's do another. Okay. Second problem here. Mr. Thomas cooked 45 hamburgers and hot dogs at a cookout. That's what we need for the first equation. I'm going to use H for hamburgers. And then I'm going to use D for hot dogs. So I'm just going to put D for dogs. Okay. I know that the hamburgers and hot dogs put together equals 45. Second sentence is about how they're related. He cooked twice as many hot dogs as hamburgers. So there are 2 times more hot dogs than there are hamburgers. So in other words, if I take 2 times the hamburgers, then I get the number of hot dogs. Take the smaller one times 2, get the bigger one. So there's my equation. I've already got one variable by itself, so I'm going to take this expression for D and I'm going to plug it into my other equation in D's place. So I'm going to rewrite H plus D, but I'm going to put H plus 2H equals 45. So that really means 3H equals 45. So H would be 15. So there are 15 hamburgers. To get the number of hot dogs, I'm going to plug that 15 in for H. I need to know what D equals, so I'm going to use the equation where it says D equals. So 2H equals D really means 2 times 15 equals D. So there are 30 hot dogs. And it said there were twice as many hot dogs as hamburgers. So 30 hot dogs, 15 hamburgers. Got 3 more, I believe. 7 people went to the movies. The number of adults was 1 more than the number of children. Okay, hold on a minute. So I'm dealing with adults. I'm going to use A. And children. I'm going to use C. And I know that there were 7 people total. So adults plus children, A plus C equals 7. Second equation is going to be how they're related to each other. It says the number of adults was, so the number of adults equals 1 more than the number of children. So 1 plus whatever C is. There's my system. To solve my system, I'm going to take this expression for A and I'm going to put it into the other equation in place of A. So instead of saying A plus C, I'm going to say 1 plus C. Whoops. There we go. 1 plus C. And then I still have plus C equals 7. So that becomes 1 plus 2C equals 7. I'm going to subtract the 1 from each side. And I get 2C equals 6. Divide by 2, and I find out that C equals 3. So there were 3 kids. To get the number of adults, you're going to plug that back into the equation and solve it for A. So if A equals 1 plus C, that means A equals 1 plus 3. So A equals 4. There were 4 adults and 3 children. 2 more. Elaine bought a total of 15 shirts and pairs of pants. Okay, I'm going to say S is for shirts. Really creative here. I'm going to say P is for pants. First equation is going to be about their total. So shirts plus pants, S plus P equals 15. Second equation shows the relationship between the two. She bought 7 more shirts than pants. So if I take pants plus 7, I get shirts. Or you could say shirts minus 7 equals pants. I tend to steer away from negatives and minus if at all possible. Okay, so there's my system. I've already got one variable by itself, so I'm going to take this expression and I'm going to replace S in the other equation with it. So instead of saying S plus P, I'm going to say P plus 7 plus P equals 15. Put those like terms together and it says 2P plus 7 equals 15. Subtract 7 and I get 2P equals 8. Divide by 2 and P equals 4. So I believe she got 4 pairs of pants. To get the number of shirts, I'm going to take that value for P and plug it into this equation here. So instead of P plus 7, I'm going to say 4 plus 7 equals S. So 11 equals S. She got 7 more shirts than pants. So she got 11 shirts and 4 pairs of pants. Last one. Maybe. Together, Preston and Horatio have 49 video games. Okay, so I'm going to use P for Preston. Even though these are representing names and names are capitalized, variables should always be lowercase. So I'm using lowercase p and lowercase h, but those are representing Horatio and Preston. I know that together they have 49, so P plus H equals 49. Horatio has 11 more games than Preston. So if I take Preston plus 11, I get Horatio. Now to solve this system, I'm going to take this expression for H and put it into my other equation in place of H. So instead of P plus H, it's going to say P plus 11 equals 49. Put your like terms together, and that says 2P plus 11 equals 49. Subtract 11, and you get 2P equals 38. Divide by 2, and you get that P is 19. So I think Preston has 19. To get Horatio's, I'm going to plug that answer back into this equation here instead of P. So I'm going to say 19 plus 11 equals H. So 30 equals H. So Preston has 19 and Horatio has 30. That's that. Just remember your first equation needs to represent the total, and your second equation shows how they're related. Hopefully that helped. Thanks for sticking it out to the end. Let me know if there's anything I can help you with. Until next time, bye-bye.